Hello, I'm Michael McTear from Ulster University in Northern Ireland. I'm very proud to have the opportunity to present at the Chatbot Africa and Conversational AI Summit, and I would like to thank Sydney and Benjamin for inviting me. A few words about myself. I've been working with dialogue systems, also known as conversational assistants or chatbots, for more than 20 years. Currently, I'm working in a number of projects involving chatbots in domains such as mental health support and the care of older people, and this is the topic of today's presentation. Conversational assistants are everywhere, on our smartphones, in our homes, and in our cars. We can interact with some of them by speaking to them, and with others by typing or clicking on buttons. In most current cases, the interaction with a conversational assistant is fairly simple. For example, we usually talk to Amazon Alexa or Google Assistant using a single query or command. People distinguish between two different types of conversational assistant. Task-oriented assistants are used to perform a particular task, such as scheduling a meeting. With these systems, the main thing is to be able to complete the task successfully and efficiently. These can be contrasted with chit-chat systems, also known as social bots, where the aim is to engage in a coherent and engaging conversation, but without necessarily performing a particular task. Chatbots for social good combine aspects of both these types of system. They fulfill various purposes, such as providing health care and mental health support, monitoring older people at home, acting as a conversational companion, and supporting active and healthy aging. In current systems, the conversations are usually fairly simple and well defined. For example, to check if a person has taken their medications. But in the future, they're likely to become more complex and to involve multi-turn, open domain conversations. In today's talk, I want to consider the following questions that are particularly relevant for designers and developers of chatbots for social good. What do the users of chatbots want and expect from conversations with these systems? What is technically feasible in the current state of the art? And thirdly, what are the safety and ethical considerations associated with the use of these systems? Looking first at user requirements, how do we know what users want as opposed to what designers and developers would like to create? To answer this question, I will briefly describe how we are eliciting user requirements in some projects that I'm involved in. In ChatPal, which is an EU project in the Northern Periphery and Arctic programme, we are developing and trialling a chatbot to support and promote mental well-being in rural areas. MENIR is an EU-funded project in which we are developing conversational technologies to help people with mental ill health manage their conditions. Evita is a new joint EU and Japan project that has just started, in which we will develop a virtual coaching system that will promote active and healthy aging to help older people to live independently. In each of these projects, we're using a process of co-creation with living labs, focus groups and workshops to elicit user requirements and develop functional specifications. For example, in the Chatpal project, the participants in the workshops were mental health service users, mental health care professionals, and designers and developers. The participants were shown video demonstrations of current mental health chatbots, and they discussed various topics, such as the pros and cons of using chatbots in the context of mental ill health, what sorts of conversations users would want to have with the chatbot, and issues of privacy. Some of the functionalities that were identified included mood tracking by monitoring changes in the user's emotional state over time, intelligent reminding, and motivating by suggesting useful activities, as well as providing links to resources and services. In the course of our workshops, we've become aware of conflicts between user requirements and what is technically feasible. There are two sides to this problem. On the one hand, users might overestimate what is possible. For example, they might not appreciate the limited extent to which current systems can engage in an open and meaningful conversation. And then on the other hand, they might underestimate current technology. For example, they might not be aware of what is possible and only envisage simple types of interaction and functionalities, whereas richer and more complex ones are actually possible. This brings to mind what Henry Ford, the founder of the Ford Motor Company, allegedly said about asking users what they wanted. If I'd asked people what they wanted, they would have said faster horses. For this reason, it is important for designers and developers to engage with users, for example, with simulations, to clarify what is feasible and what is not. Turning now to the technology of conversation assistance. To put it simply, there are two things that a chatbot needs to be able to do in a conversation. First, it needs to be able to understand what the user says to it. And secondly, it needs to be able to produce a sensible response. This is assuming a simple dialogue consisting of a user input and a chatbot response. In a longer conversation, things become more complicated, and the chatbot has to remember what was said earlier in the conversation. Technically, this is known as dialogue state tracking. This is all easier said than done, and there's a vast amount of current research in this area which I won't have time to cover in detail, but those who are interested might wish to look at my recent book, which provides an overview of past and current research in conversational AI. There are two main approaches to creating chatbots: the traditional rule-based approach and the neural dialogue approach using machine learning. Rule-based conversation assistants are designed using best practice guidelines, as described, for example, in Kathy Pearl's book. There are many toolkits that can be used to develop chatbots in this way. This book by Srini Janarthanam provides an excellent overview. Conversation designers are very much in demand nowadays, and there are many training courses, tutorials, books, and blogs that describe and address chatbot and conversational design. Regarding the interpretation of the user's input in the rule-based approach, there are several possible solutions. Firstly, avoid the natural language issues altogether by specifying the user's input as predetermined buttons, which are also known as quick replies or suggestion chips. Secondly, allow natural language input, but to design the assistants or prompts so that the user's inputs are hopefully limited to those specified in a grammar handcrafted by the designers. Or thirdly, allow free natural language input and use machine learning to process it by classifying its intent and extracting relevant entities. This is the approach favoured in more advanced toolkits for creating chatbots such as Dialogflow, Alexa Skills Kit, Microsoft Bot Framework, Rasa, and others. Turning now to the system's output and how the general flow of the conversation is managed. In the simplest case, which is suitable for use cases where the conversation is well defined and constrained, the conversation flow can be mapped out in advance in a conversation graph, as shown here in the diagram on the right hand side. In this graph, the assistant's prompts and responses can then be defined. A limited form of flexibility in the response would make use of templates with slots to be filled with values from the interaction or from some other knowledge source. The rule-based approach has the advantage that its behaviors are under the control of the designer. However, rule-based systems are costly to develop, they don't scale very easily, and they don't change unless they have been manually updated. An alternative approach that has come to dominate research in conversational AI is to use machine learning instead of handcrafting. In this approach, conversational assistants are trained from large corpora of dialogue data. In this way, they learn how to classify the user's responses and to determine the system's actions and outputs. The most recent trend is an end-to-end approach in which input utterances are mapped directly to output responses. This is known as sequence-to-sequence mapping, and in this approach, it's implemented in an encoder-decoder architecture. The user's input is encoded using some form of neural network. In current approaches, normally transformers are used, and then a response is generated through a process known as decoding. Some recent examples of systems developed using this approach are Google's Mina and Facebook's BlenderBot, as well as the social bots developed in the Amazon Alexa Prize. Impressive results have been obtained using neural dialogue approaches, as shown here in Conversation B with Google's Mina. However, often nonsensical conversations are produced, as shown in the dialogue on the right-hand side, where the system gets into a repetitive loop in the second half of the example, continuously saying, "I'd love to go to Japan," irrespective of what the user has said. Other problems that occur with these systems include bland and uninformative responses, such as "okay," "that's fine," and semantic inconsistency, where the system says something that contradicts what it had said before. For example, "My age is 27," where previously it had said, "I'm 45 years old." It has also been found that conversational assistants trained on data sometimes produce responses that might be offensive, inappropriate, or even harmful. Which brings me now to the third question mentioned earlier: what are the safety and ethical concerns associated with conversational systems? Looking first at privacy. There's a dilemma that if systems are going to provide useful services for the user, such as reminders to take medications, then they need to store information about the user. Issues include who owns the data, who has access to it, how and where the data is stored, on the user's devices, that is, on the edge, or in the cloud. Nowadays, projects are obliged to make a declaration about data protection and data storage, although these requirements can vary across different jurisdictions. In the case of explicitly elicited information, the user or carer may provide consent for the required information to be collected, stored, and used, and user-sensitive data may be stored on the user's devices and not in the cloud. However, as systems become more complex, there may be information about users that is inferred from the conversation logs rather than explicitly stated. For example, by estimating sentiment, mental distress, suicidal intent, or other critical information about the user. This is likely to involve complex processes of reasoning and analysis that can only be performed using large external computing resources in the cloud. Thus, reconciling the user's privacy with a desire to provide greater utility remains a challenge for current research. Offensive content and bias are also major concerns. Regarding offensive input to the chatbot, Steve Warzek, for example, reports that 30% of the input to the chatbot Mitsuko consists of abusive messages, swearing, and sex talk. So-called sensitive content was also a major concern in the Alexa Prize competitions. One of the ways this has been addressed is to use a sensitive content filter. Another way is to make use of strategies to direct the dialogue in a different direction. A chatbot might also output offensive content. This occurs when conversational assistants are trained on publicly available data sources that might contain sensitive content. Bias is another problem. There may be a lack of diversity in conversational assistants that can arise from training data that excludes, for example, people of color or from different religious and cultural backgrounds. There's also an issue with gender bias, as most conversational assistants that are voice-based on smart speakers and smartphones are female. In other words, as the authors of the book The Smart Wife have put it, they are feminized. A final issue that is particularly relevant in domains such as healthcare and mental health support is that a conversational assistant might produce inappropriate and possibly harmful responses. There have been many examples reported in the literature, for example, in studies by Timothy Bickmore and others. The example shown here is from a study by a team of doctors and machine learning engineers from Nabla, a Paris-based firm specializing in healthcare technology. In this experiment, a cloud-hosted version of OpenAI's language model GPT-3 was used to determine whether it could be used for medical advice, with disastrous results, as could be seen. Although in fairness, it should be noted that OpenAI does warn against the use of their model to provide medical information or advice, particularly in life or death situations. To wrap up with some takeaways, there's a new type of chatbot or conversation assistant that has been used in domains of social good. This type of chatbot will combine elements of task-oriented and open domain conversational systems. It is important to elicit comprehensive user requirements and to ensure that these are realistic in terms of current technology. Chatbots for social good are particularly susceptible to issues of privacy, offensive content, bias, and safety, and so it is important to consider these issues in relation to the design, development, and deployment of these systems. Thank you for your attention.